Victories of the Day, March 23. 1840, the first detailed photograph of the Moon. John William Draper successfully produced the first detailed daguerreotype of the Moon, marking the birth of astrophotography. Before this achievement, the Moon could only be recorded through hand-drawn sketches, which were subject to human error and lacked the precision needed to map lunar craters or seas accurately. The system utilized the daguerreotype process, using silver-plated copper sheets sensitized with iodine vapor and exposed through a telescope for a grueling 20 minutes to capture enough light. This shifted astronomy from a purely observational hobby into a data-driven physical science, proving that chemical sensors could record details of the universe that the human eye might miss. This framework is the direct ancestor of high-resolution digital imaging. It proved that the camera was the most essential tool for understanding the cosmos. 1868, the founding of the University of California. The charter for the University of California was signed, establishing a dedicated research hub for agricultural science and mechanical engineering. Prior to the mid-19th century, higher education focused largely on the classics and law, failing to provide a structured environment for the large-scale laboratory research needed for an industrial society. The university was designed as a land-grant institution, meaning its primary mission was the application of chemistry and physics to solve real-world problems like soil salinity and seismic safety. This shifted the landscape of global innovation, creating a model where government, industry, and academic researchers collaborate to push the boundaries of technology. This institution eventually became a powerhouse of discovery, leading to the creation of the cyclotron and the development of early Internet protocols, ARPANET. 1950, the establishment of the World Meteorological Organization, WMO. The United Nations officially transformed the International Meteorological Organization into the WMO, creating a global network for the science of atmospheric physics. Before 1950, weather data was fragmented by national borders. A storm crossing from one country to another was often lost to researchers because there was no standardized way to share pressure and wind data. The system established a global telecommunications system that allowed every nation to exchange weather observations in real time using a universal mathematical code. This shifted meteorology from local observations into a planetary-scale science, allowing for the creation of computer-generated weather models that could predict hurricanes days in advance. Today, this global coordination is the only reason modern society can manage aviation safety, agricultural planning, and climate change monitoring. 1971, the elimination of smallpox in the Americas. Health ministers finalized the data showing that Brazil, the last stronghold of smallpox in the Western Hemisphere, had reached 0 cases, a milestone in preventative medicine. Before 1971, smallpox was a global threat that killed millions and left survivors with permanent scarring because no country could eliminate it in isolation. The system utilized the bifurcated needle, a simple engineering tool that allowed non-medical volunteers to deliver the vaccine with 100% efficiency in remote areas. This shifted global health strategy from mass vaccination to surveillance and containment, where doctors tracked a single case and vaccinated only the surrounding ring of people. This ring vaccination strategy finalized for the Americas on this day is the exact same method used today to stop outbreaks of Ebola and other infectious diseases. 1983, the validation of in utero surgical theory. Medical researchers finalized the first successful large-scale data set regarding fetal surgery, proving that life-threatening defects could be repaired while the baby was still in the womb. Previously, many birth defects were considered incurable, because waiting until after birth meant the damage to organs like the lungs or spine was already irreversible. The system utilized high-resolution ultrasonography and microsurgical tools to navigate the delicate environment of the uterus without triggering premature labor. This was a triumph of pediatric surgery, showing that the womb could be treated as a surgical suite rather than a closed black box. This achievement is the foundation of modern maternal-fetal medicine, allowing doctors to perform life-saving heart or spinal repairs on a fetus. 6. 1989, the cold fusion controversy. Stanley Pons and Martin Fleischmann announced they had achieved nuclear fusion at room temperature, sparking a massive debate in nuclear physics. Previously, nuclear fusion was thought to require millions of degrees of heat and massive gravitational pressure, making it an impossible engineering task for a small laboratory. The system involved an electrolytic cell with palladium electrodes and heavy water, which the researchers claimed produced more heat energy than was put in. This shifted the scientific community into a state of extreme peer review, as laboratories worldwide raced to replicate the results, eventually failing to find consistent evidence. While unproven, this event led to a massive increase in funding for low-energy nuclear reactions, LENR, and taught science how to better manage pathological science through verification. 7. 2001, the controlled orbit of the Mir space station. The Russian space station Mir was intentionally deorbited, crashing into the South Pacific and marking a milestone in space salvage and ballistics engineering. Prior to this, the world had never attempted to bring a 135-ton structure back through the atmosphere in a controlled way, posing a risk of debris hitting populated areas. The system utilized a Progress cargo ship to fire its engines in reverse, precisely slowing the station so it would burn up over an uninhabited region called the Spacecraft Cemetery. This achievement was a triumph of orbital mechanics, proving that we could safely decommission massive space structures once their operational life was over. The data from Mir's final descent is currently being used to plan the eventual retirement and safe disposal of the International Space Station, ISS, in the 2030s. 8. Scientist of the Day, Emmy Noether, March 23, 1882 to April 14, 1935. Emmy Noether is the dedicatee of March 23 for discovering the mathematical link between symmetry and physics. While Einstein is famous for relativity, it was Noether who proved why laws of physics stay the same over time. Her Noether's theorem showed that for every symmetry in nature, like the fact that physics works the same today as it did yesterday, there is a corresponding conservation law, like the conservation of energy. She is widely considered the most important woman in the history of mathematics, as her work provided the grammar that all modern particle physics and quantum mechanics are written in today.